Hi, Eric here with 30x40 Design Workshop. In part 5 of our model making series, I'm going to demonstrate the techniques and methods you can use to build your own architectural models. And to do that, we're going to build this small study model as an example. I'll walk you through each step along the way from start to finish, so let's get into it. Now you'll recall from part 1, every model begins with a defined purpose. Ours will be a study model, used to test exterior shell design ideas, a variety of elevation compositions, material options, roof forms, and the interior-exterior spatial relationships. Architects use study models as design tools. They act as sort of three-dimensional sketches. They're meant to be altered and to be used for experimentation. So this one isn't pristine and perfect. You'll see that not everything lines up or is completely glue-free, and that's okay. I think of study models as frameworks I can use for experimentation. Now the next step is to choose a scale. You'll need to know the rough size of the building before choosing one. Studying a 200,000 square foot building at 1/4 inch scale would be really difficult, but a 2,000 square foot building is much more manageable. Use the rough footprint of your building along with the level of detail you're hoping to render to choose a scale. This is highly dependent on your program, but for my residential work, study models range between 1/16 of an inch scale and go up to about 1/8 of an inch scale, while more detailed models begin at 1/4 inch scale and go up from there. The larger the scale, the finer the level of detail you're going to be able to study, but equally the more exacting you'll have to be in rendering materials and details. Usually when you're just starting a design, you don't know enough about the building to build a 1/4 inch scale model, and it's also very resource intensive. The footprint for our case study barn project is roughly 18 feet by 40 feet, and I chose 3/16 inch scale. This means in real terms that the structure will be about 3.5 by 7.5 inches, enough to highlight some of the siding and fenestration details, yet not so big that I have to figure out more things that I'm ready to at this early stage. Here I'm using 2 stone tile samples. I've added felt pads to the underside, making them table friendly and also providing a little shadowed reveal. Stone tile samples can be sourced many places online. On this base, I've added another small slab of limestone tile which I've cut to match the building footprint. It's not important that you use tile or any other precious material or even that you mimic this one, but your building should rest on some sort of foundation. Every building has a relationship to the ground plane. This one sits on a plinth or a raised base. Yours might be excavated into or raised above it. Now I've chosen inexpensive, easily sourced materials for this model, a combination of basswood scraps I had lying around and 2 thicknesses of chipboard, 1/16 of an inch and 1/32 of an inch. If you make your study models out of less expensive materials, you'll have an easier time using it as the design tool it's meant to be. Once we've gathered our materials and the tools we discussed in part 3 of this video series, it's time to begin fabrication. If you're a pro with a utility knife, feel free to skip a little bit ahead. Otherwise, here's a few cutting tips. Number 1, change blades often. Dull blades tire your hands and they damage materials. Using dull blades is a shortcut to looking like a novice, and although a dull blade won't properly cut your building materials, it will easily cut you. Number 2, use multiple passes. For everything but very thin sheets, use your first pass to score the cut, the second to dig deeper, and successive passes to finish. Material thickness will make a big difference in the number of cuts you'll actually need to make. Number 3, use light pressure. Strong downward pressure can lead to slips and cut fingers. And number 4, rotate the knife down as you exit the cut. This gives a cleaner finish at the end. Lastly, you want to use a metal ruler. Plastic ones are easily cut by sharp blades. Now there's a number of different cut types. There's the through cut, which is the most straightforward one, assuming you use multiple passes. When cutting openings in a wall, like a door or a window, start at an inside corner with the tip of your blade to begin the cut, stopping just short of the next corner. Turn your material and do the same for each inside corner. For a 4-sided opening, this will mean 8 inside corner cuts in total, 2 per corner. This technique minimizes overcuts at the corners. Number 2, scoring. Scoring is a partial cut through the material. This is done to mimic material joints or to create hinge points, say for a wall bend or a roof plane. Good model makers use this cut almost as often as the through cut to save time. Why cut two separate planes and glue them together when you can cut one with a score and simply hinge the joint? Specialty cuts. Materials like acrylic, metal, wood, and others have special cutting equipment. Be familiar with the cutting methods best suited to each material. Having once tried to cut metal wire on a bandsaw with a wood blade, I can say it was an experience I won't ever forget. For this model, the only specialty cuts I made were to the wood elements. I used a razor saw to achieve clean, perpendicular cuts. Lastly, a laser cut. Using a laser cutter is a time-saving means to producing complicated cuts, but I find it takes some of the experimentation out of model making for me personally. But in the right hands, it can be a fantastic tool, and it cuts acrylic like nothing else. The barn study model doesn't have a set of drawings I'm working from. I'm designing and changing things as I build. If you're building a presentation model, which is basically a direct representation of your design, you'll likely have drawings as a starting point. If you do have scaled drawings, a common workflow is to begin by spray mounting the drawings to a base plate, like chipboard. Then you'll cut the floor plate or plates out and then either scribe the walls onto the base or simply use the plan as a template for laying out and gluing your walls and additional floor plates in place. If you leave the plan in place, consider how it will impact the finished look of the model. I prefer the look of scribing and removing the printed sheet and constructing the walls on top of that to leaving it in place. It's a more professional look. Because I'm designing with a purpose but not a floor plan, I have a basic layout I'm working with and general starting dimensions, but I'm presuming the model building exercise is going to change those assumptions and present new opportunities. This is the true value of a study model. It's a place to experiment with your ideas, and I find this happens best when I don't work from a set of pre-designed plans. Either method can work though, and you should probably try both. With either, you'll need to plan ahead. Model building is as much about planning as it is about constructing. Knowing where the stairs will be or how you're going to fasten the walls together will inform how you cut them and what material thicknesses you'll need to account for. Will the corners butt, bypass, or miter? Your plan should include exactly what you're planning to model, spaces, forms, or a combination. Now, I prefer to model the reality of space, and so my models are usually comprised of planes rather than solids. Scale will determine this too. It would be impossible and really unhelpful to model the spaces in a small-scale urban massing plan, for example. Using planes to represent spaces naturally lends detail and expression to the model. It's these things, for me, that spark new ideas and suggest new relationships I hadn't considered before. To plan this build, I know I want the freedom to modify a few key things. First, the exterior massing and roofline of the building. Second, the exterior facades and materials. And lastly, the interior structure. This means upon my base, I'm going to first build the bones or structural core. This will be the framework I can then layer the exterior facades and begin experimenting with the building form. Breaking a building apart into systems is a natural way for architects to think and design, and it will make your model building easier. Examples of systems are walls, doors, window, structure, foundation, roof, landscape, and of course there's many others. Each of the study model systems will be removable in this model, so I can tweak as I go along. It's not necessary that you separate the building this way, and in fact, for small-scale study models at an early stage, the fewer the systems, the better. But they may incite ideas you hadn't considered before. We'll start by building the interior timber frame, beginning with the posts, then layering on the girts and the floor framing, then the floor, and finally the roof. You want to think about the real physics involved. There are various ways to detail a timber frame: bents, bearing ridge, purlins, etc. So this isn't a hyper-realistic rendition, but it has to be sensible from a physics standpoint or it will just look wrong. Building a model forces you to confront physical reality in a way that computer modeling doesn't. You'll see how spindly a column is or how a shear wall works quite explicitly when you build this way. Templates are the best way to duplicate results in modeling. To cut our columns to the same length, I set up a template or a jig by cutting a notch in one corner of a piece of basswood. I measured the column length and taped the jig in place on my cutting mat so I could slide my column stock into place and quickly cut along the cut registration line. This saves a lot of time. I created one for the rafter layout too, and the siding strips using a similar technique. Next, I'll lay out the walls. Now this can be done by drawing on the chipboard or basswood the design idea and cutting out the wall plane. If you have drawings, spray mount and cut them out. Consider lining up the drawings in a way that will allow you to score the corners as discussed earlier to save time. Just make sure you account for the material thicknesses as you wind your way around the building. This helps to ensure that the last corner lines up just as you expected. If you have multiple floor plates, these can help brace the wall planes as you stack them up. To reinforce the corners, cut the angle you want to maintain out of chipboard and glue it in place. Consider whether they'll be visible or not, or whether you care. For a more detailed explanation of glue types, be sure to watch part 3. Here I'm using white PVA glue for the fine vertical details and thin chipboard, hot glue for the thicker chipboard and structure, and double-sided tape for laminating wood elements. Hot glue is fine for study models, but it's not the best for more finished presentation quality ones. I like it because it dries almost instantly and I can easily remove it without a lot of material damage. When you use hot glue, apply it to the smaller of the two pieces you're working with. A column end, for example. This ensures you're applying the right amount to the piece and not overdoing it. With hot glue, you'll get lots of strings falling all over your model. Clean these off by moving the hot tip through and around the model when you're finished to sever the threads. Clean up any blobs before moving on too. When using PVA glue on materials like basswood, the water in the glue will often cause it to warp. Fix this by reinforcing it on the opposite side. It's important to keep a clean work surface and clean hands when you're building a model. Depending on your speed and glue type, plan to wash your hands at least once every 30 minutes. It doesn't sound like it, but this will actually save you time later and make for a better quality product. The less gunk and grit you have around on your desk, the less your hands will pick up. A clean desk means you'll waste fewer materials and you won't spend time looking for things. I use aluminum trays to organize things and spread craft paper on the table so I can label designated areas for material assemblies like beams and columns. I also have a small desk brush from Muji that I picked up for a few dollars that helps keep things tidy. The exterior walls can have as much or as little detail as you choose. One of the stated goals for this model was to render the materials. Some of this I'll do with paint, some with alternative material choices like metal or laser cut paper, and some I'll do by layering on thin chipboard. To make these walls, I took a base wall plane, added a few verticals to simulate strapping, and glued on my siding planks to represent an open rain screen cladding. Adding detail and shadow, even in a small scale model, can really improve the realism and subtly suggest effects you can't realistically duplicate. Now, all modeling requires some suspension of reality. It's good to get close, but not really important that a barn door track, for example, be represented as 2 3/4 inches tall as it would really be. I'll add a thin horizontal strip of chipboard painted silver to represent this in the model. Now, if I were to make it the actual 2 3/4 inches wide, it wouldn't even be worth modeling. But I want to suggest it and use it as a visual tool. The vertical strapping is another example. I didn't space it 2 feet on center as you normally would, but rather 10 feet on center. But it still renders the effect we're going for. This shorthand saves construction time. You can do this everywhere on your model. Use details to show design intent rather than to necessarily accurately represent reality. Smaller scales allow for more artistic interpretation, while larger scales will require you to pantograph reality more closely. For the roof, I used the scoring technique to create the pitch break at the ridge and the corner technique discussed earlier to maintain the roof pitch. The roof is easy to make removable, and I'll be experimenting with different options along the way. This also shows off some of the interior, so plan accordingly. For me, the details are what animates a model. Be sure to watch the first video in our series for more on the value of narrative in model making. The details I've added here are the elongated and oversized roof gutter, which describes an attitude toward water collection and addresses site conditions. It also suggested a design idea to capture water and use it for reflecting light to the interior of the barn. Next, bracing on the hinged barn doors. The doors would be heavy and require bracing to keep the outer edge from sagging. Indications of real-world materials. Check out the ridge on the roof. All metal roofs have a cap to anchor and flash the pans. A simple scored covering does this, and it also adds shadow. I've also added pencil marks to simulate material sizes and joint patterns. There's scale figures. Here I simply painted a few model train figures black and added them to the model. Trees. These are super trees, and I like them because they aren't so abstract as to be confused for something else, like a wood dowel, for example. The level of detail for any landscape elements should align with the level of detail used elsewhere in the model. Other landscape indications. Carpet samples, especially low pile ones like this one from Floor, work well for simulating turf. Now, if you've learned something here, please hit the thumbs up down below and the subscribe button. You can help me by sharing this around, which allows me to grow the channel and tells me that I'm making the kinds of videos you want to watch. Cheers.